So hello guys, today we are meeting again. So today we will be learning a completely different thing, but this thing is needed in your JEE and NEET syllabus. From the board's point of view, it's not that much needed, but the whole thing is very much needed and very important if you are a JEE or NEET aspirant. So without delaying any further, let me just get into the topic. So today's topic is related with organic chemistry. Now in organic chemistry, you have heard about many name reactions. So one of such name reaction is our Reimer-Tiemann reaction. Now what happens during Reimer-Tiemann reaction? Here you can see a molecule of phenol. So a molecule of phenol reacts with a molecule of chloroform in presence of aqueous NaOH to produce salicylic. Meaning, well, if we just speak purely from the changes taking place perspective, then you can say that by this reaction we are able to replace this hydrogen by an aldehyde group, that is CH2. So if you take a closer look to our substrate, which is phenol here, and our end product, which is salicylic here, you will be able to see that in the substrate we didn't have any aldehyde group in this or this position, but in the product we do have an aldehyde group in the ortho position with respect to phenol. So let's now take a deeper dive and let's take a look at how this reaction occurs. Meaning, let's see how the mechanism works out. Okay, so as we all know, in phenol molecule, the lone pair of oxygen, it can be contributed, or it can be, the oxygen can send that lone pair into the benzene ring, so that we will see a resonating effect like this. So this is the resonance which takes place in the normal phenol molecule. So as you can see, the negative charge or the electron is getting placed predominantly at the ortho, para and ortho positions. So this means that the ortho and para positions of phenol molecule with respect to hydroxyl group, namely these three positions, become excessively electron rich, which actually helps in the aromatic electrophilic substitution of phenol. So let's come back to our original mechanism. Then, if in normal phenol molecule we can see a resonance as I showed you guys before. So in this case also we will be expecting a resonance of the same kind, and indeed it is the type of resonance which we see. As a result of that, what happens is the chloroform molecule which is present in the reaction mixture, this carbon gets attacked via the ortho position. Now why this carbon gets attacked? Because see, here we have 3 chlorine atoms attached with carbon. So that makes this carbon very much electron deficient. So as this carbon is very much electron deficient, and as on the ortho position we have an excess of electron density, so the attack takes place to this carbon atom via the ortho position. So the result, as this attack takes place also, this carbon leaves a chloride ion. Why? Because see, in this chloroform molecule we have 1, 2, 3 and 4 bonds already existing with carbon. So if carbon wants to make another bond, it is not permitted to do so, because if it's going to make another bond, that will be the fifth bond for the carbon atom, which is not permitted. So hence carbon must break at least one bond. So the CCl bond is broken. So in this case, after the attack, we are left with something like this. Now as you can see here, we have a positive charge. Now this positive charge means that the aromaticity of benzene ring has been lost. Now benzene ring will not allow that, as aromaticity provides an extra stability. So what does the benzene ring do in order to get back the aromaticity is, this CH bond, it gets sacrificed and the benzene ring again regains its aromaticity. Now if you remember, we had aqueous NaOH. Aqueous NaOH means we will be having Na plus and OH minus ions in the reaction mixture. So in the whole process, what happens, phenol does not only lose this CH bond but also loses this hydrogen. So as a result, we will not have any hydrogen atom here, rather we will have a phenoxide anion like this, because the OH minus picks up that hydrogen, because that has an acidic character attributed to that. At the same time, the hydroxyl ion can attack this carbon also. Again, the reason is same, because this carbon is still attached to two chlorine atoms. So this leads to a deficiency of electron or this carbon atom. So as a result of this attack, another Cl atom which leads the attack. So now we have a compound of this, but still hydroxyl ions are present in the reaction mixture. So what happens is, another hydroxyl ion again attacks this carbon. As a result of that, the last CCl bond also gets broken and we end up having a Jane diol. Why Jane diol? Because in this case, you see, both the hydroxyl groups are attached to this same carbon. So that makes this compound a Jane diol. Now in this case, one of the two OH groups can contribute its lone pair to the adjacent carbon, so that another OH group leaves. So if that happens, we will have something like this. The OH group which was removed from this carbon now picks up this hydrogen and the positive charge on the oxygen is released. So at the end of the day, we have an aldehyde group attached at the ortho position of the initial hydroxyl group of phenol. So in this product, if we treat it with acidified H2O, then this sodium will be replaced by OH group. Which was our final product. So this is the whole mechanism of Reimer-Tiemann reaction. I hope you guys have understood it, and if you have any doubts or any further queries, you guys can just write them down in the comment section. Bye.